So this is the last lecture of undecidability. We have already seen decidability and undecidability. We have already seen what is the difference between recursive language and recursively enumerable languages. We have already seen halting problem using the undecidability, then Rice theorem. Now we will see the post correspondence problem. Now the post correspondence problem is an undecidable problem that was introduced by Emily Post in 1946. So this was introduced by a scientist named Emily Post in the year 1946. Now how does this work? We will see that. So there is a dominoes. 4 pieces of dominoes are given. We need to find the sequence of dominoes such that the top and bottom strings are same. So we have to arrange them in such a way that the top and the bottom string are same. So how will we do this? So first suppose I am taking the dominoes piece A and I am taking AB in the bottom. So now I have an extra B in the bottom, so I need a B on the top. So I take B and on the bottom I take CA. Now I have A, B, C, A. So I need a CA on top. So I get a top A, B, C, A and I get an extra A. Now I need an A on the top. So I have here A. I need an A on the top. So I write here A and I write here AB. Now I have a AB extra. So I have A, B, C and a C. So now if you see this sequence, then what do we observe? We observe it is A, B, C, A, B, C, and if we observe this sequence, we have A, B, C, A, B, C. So these two sequences are exactly matching. So we say that we have satisfied the post correspondence problem. Let's see one more way. So we'll write this question as, we'll see one more way. So another way of a PCP, that is a post correspondence problem. So another way of post correspondence problem is somewhat like this. I have been given 1, 2, 3 over here, A and a B over here, and I've been given sequence 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, and I've been given 1, 0 and 0. So here I have a I, that is the sequence A and a B. So first I am taking 2. So first I am taking the 2. So for A, if you see 2, you have 1, 0, 1, 1, 1, and for B you have 1, 0. Now for B I need a 1. So I will take the first sequence because I have 3 ones. So 1, 1, 1, and here in the A I will write 1. Now I have an extra 1 in A, but I have a less 1 in B. So again I will go with 1. So in the B I will get 1, 1, 1, and in A I will get a 1. Now I need a 1 in the A, right? So I will go with 3. If I go with 3, I get a 1 in the A and a 0, and B is 0. So this is the sequence of post correspondence problem which I have got. So by looking at these two questions, you might think that how can this become undecidable? We are getting the sequence, right? So you may think that how can it be undecidable, but actually these kind of problems can turn out to be undecidable. How? Let's check. So let me take one more example wherein I will show you how can this problem of PCP, that is a post correspondence problem, be undecidable. How can this be undecidable? Okay, so let's see. So you have 1, 2 and a 3, and here you have a and a B. So we have 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1, 0, 1, 0, 1, 1. So suppose there is a sequence I, A and B. So I am taking a 1 first. So when I take a 1, I have 1, 0 and here I have 1, 0, 1. Then again I am exploring a 1. So I have here 1, 0. Here I have 1, 0, 1. So I am left with an extra 1. So if I see here, instead of an extra 1, if I see this, here this 1, 1 correct, 0, 0 correct, 1, 1 correct, but here it is a 0 and here I have a 1. So this is not acceptable. So this sequence will be rejected. Let's see one more. I, A, B. I am starting with a 1 again. So I get a 1, 0. Here I get a 1, 0, 1. And then I take a 2. So for 2, if you have 0, 1, 1, here you have 1, 1. 1, 1 is proper. 0, 0 is again proper, but 0, 1 is not allowed. So again, you reject this sequence. So this sequence is also gone. This sequence is also gone. Let's check for one more pattern. I have a I, A and a B. I am starting with a 1. Here I have 1, 0. So I write a 1, 0. Here I have 1, 0, 1. So I write a 1, 0, 1. I am taking a 3 now this time. So when I take a 3, I get 1, 0, 1, 0, 1, 1. So here if you see, it is matching. Everything is matching perfectly. But I have an extra 1. Again I will take a 3. Then I will get here 1, 0, 1, 0, 1, 1. Again if you notice, everything is matching. Again take a 3. But if you notice, every time I will take a 3 now, I will get this extra recurring 1 in the B part. So in the B I will get a extra 1. That means this is not a PCP, because this is not ending, this is not terminating. So we say that as we are going on with the 3 sequence, so infinite loop will be formed. Therefore this PCP cannot be solved. Therefore it is a undecidable problem. So since this PCP goes into an infinite loop, PCP goes into an infinite loop, this PCP cannot be solved. So this is a undecidability factor when you cannot solve a PCP. So I told you that it can happen that sometimes a PCP is solved, but it also can be that a PCP is not solved. So when we say that a PCP is not solved, we say that that particular PCP is undecidable. So this is the end of the chapter undecidability. So we have covered each and every module, each and every part of this module. So go through this.